What's up, everybody, and welcome back to Leilani Electronics. This is my dual channel oscilloscope. If you haven't watched the first, I did a video with a single channel oscilloscope. So really this is part two. I'm doing three different videos. I got a single channel, dual channel, and a 3-channel RGB oscilloscope. The first one was a single channel, single color. I'll put the link below for that video. This is the dual channel, dual color oscilloscope project that I've been working on. Okay, so before we get into it, don't let all the wires fool you. It's just anytime you're dealing with dot matrix displays, I got 8x8. I'm only using 4. I didn't have enough room on a breadboard for another chip, so this one won't be on. So it's 8x32. So basically you got 32 columns and 8 rows. So just from testing, I was able to get a good waveform with that particular setup. I wouldn't go no less than an 8x30, 8x32. I do have one where it's a 16x40. You can get a real good, well-defined, waveform. But this one, we can get, pretty good waveforms out of this. So I got my little handy oscilloscope to verify the waveform. So I'm gonna turn it on. Okay, now you can see from the pattern we're getting from on this oscilloscope, and it's the same one we're getting on mine. So again, this is a dual channel setup, dual color. So I got these two switches right here. When I do the PCB, this is going to be a double pole, double throw. So what I just did is I just put two switches side by side, and I just switch them at the same time. So another video, I'm going to go over the schematic and the circuit board, the PCB, which is going to be a lot smaller, and of course won't have all these wires. So again, don't let the wires intimidate you. It's this, I know it looks like a lot, but it's fairly simple. Okay, so we're going to switch this. Okay, and there we got a green. Okay, now this is I'm using the ICL 8038. So I got my two outputs, which should be a sine wave and a triangle wave. So right now this is a triangle wave, as you can see on the oscilloscope and on the this my doesnt oscilloscope. So there's the waveform. Looks exactly like, it's supposed to. So let me go back over to the other channel. And this should be my sine wave. So I'm going to adjust a little bit so we can get a little bit smoother waveform display to show you. So this is another project. I'm going to put a link for this one, my function generator board with 11 outputs, but this one just has the 3 because I used the separate chip on this, just to start us up just for this project. So again, I got PCBs coming for all these. I'm gonna do another video when they come in the mail, whenever I order them. It's gonna be a lot smaller. It's not gonna be all these wires. We're gonna be able to see everything a little bit better, adjust it, go over things and more depth. Okay, so we got our options right here on this board right here. So we're going to try to adjust this so we can get a better waveform. Okay, that flattened it out. Okay, there we go. Now we're getting, okay. Now it's becoming, okay. Okay, just bear with me a while. I try to get a nice, clean sine wave. Okay. Right now I'm just adjusting the sweep. Okay, there. Yeah, it's kind of, we're getting there. I think it's my phone. I got to get a better camera setup. I've been using my phone for years for videos, and I got to just give in and get a better setup. But okay. . See, right here I'm adjusting the sweep or the timing. Okay, let's go back over to the triangle. Okay, we got a good triangle wave from the adjustments I made on the board. So now we're going to try to get it on my scope to match this scope. Okay. Just going to tweak it a little bit. We may have to come back down here and adjust it a little bit. Okay, we're getting something there. Oh, we just had it. There it is. There's your triangle wave right there. Got it. Oh, it drifted off. Okay, so this one I don't have a trigger on it. It's just free running. I had a trigger on there, but I don't know if I'm gonna put it on the final board. But this one doesn't have it. So, but you can see the triangle wave on there. Okay. Now I have an option over here where we can adjust the. This is your vertical adjustment. See how the wave went down, to try to use all of the display. This right here is my gain. See? And this is the timing or the sweep. Now, so basically oscilloscope, what you need to build one, out of TTL or CMOS without a microcontroller. My next one, the 3 channels, is going to have a microcontroller. But this one in a single channel, you can build without a microcontroller. Now, it's not going to be that detailed like, of course, this fancy little digital one. But it's a nice project for someone just to build, just to, look at waves, square waves, sine waves, triangle waves. This is a neat project to play around with. So this is the function generator. The schematic for this is up on my website. The schematic for the single channel and the dual channel is up on the website. So you can build all this, with a 555 timer. What are these TTLs? The CMOS, I got the 4514. I got some TTLs. Now, normally I don't mix the two, but in this case, I did. So you can use them together as long as you use pull-ups. Okay, so we went over this is your vertical gain. I'm using an LM3914 for this one to give me my voltage. And again, the 555 is giving me the timing or the sweep. So basically, oscilloscope is you need something to measure voltage, and you need something that'll give you a sweep your LEDs. So for instance, these CMOSs are set up in a 1-up-32 counter. So what that is, it's going to just scroll one at a time, 1 through 32. And it's going to keep doing that. And the rate at which it does that is determined by this 555 timer. And by adjusting the capacitor on the pin 2 and 6 gives you your different frequencies of how fast or slow you want it to go. So an LM is set up so the input goes into the LM3914, and a wave is just going to go from 0 to whatever, say 9 volts. It's going to go up and down 0 to 9 volts, and that's where you get your. So those two work together, timing, sweep, and your voltage, and that's where you get your your oscilloscope, so to speak. So so when you want to interface the TTL with the CMOS, you just need a pull up. And my input stage, it goes, let me get my schematic out. It goes into my double pole, double throw. It goes into a resistor network, which cuts the waveform in half. This, I have it set up that way in case you put a 10 volt waveform into a 5 volt input. This circuit runs off of 5 volts, and 9 volts. So when we go over the schematic, I'll break it down. So the input goes into a resistor network that basically cuts the signal in half. Then that goes into a op amp. I'm using an MCP601, and that's set up to give me my my gain. So say for instance you got a 3 volt waveform coming in. Once it hits the resistor divider network, it'll be 1.5, and that way you can adjust your gain up or down to get you know, a better waveform to kind of like fill the display. Now I'm not going to get into the breakdown of each like pixel. I had a guy on Facebook reach out to me. He says, well, how do you determine the peak voltage of the waveform? You can do that. Like for instance, this on my oscilloscope down here is set for 1 volt, and we got about 1.5 blocks. So this waveform is probably between 1 and 2 volts peak to peak. So you could say, for instance, each of these dots is 0.3. So 7 times 3 is 2 volts. So, and this is where your vertical gain comes into play. So you can adjust it down to where each LED, each row is a volt or half a volt. So we can say 0.5, 1, 1.5, and so on. So the max would be 4 volts. So the waveform is 2 volts in. So if we set this for up to 4, you can say, okay, that's a 2 volt waveform. Or you can increase it up to the 8, and now you could say it's 4 volt. Okay, so let's go back over to the other channel. I hope I'm explaining this right. I'm trying to get better at breaking down how to this works. But okay, there's our sine wave. Okay, so we got our gain, our input stage, timing, vertical adjustment. We got the LM3914, and here's the schematic. I'm going to do that in another video with the PCB to show you how this all ties in together. Again, this is a neat circuit. The dual color displays that I'm using, I got from what's the website? Jamco. I'll put the link below also, jamco.com, or ledtronics.com and futurelect.com. All have dual color and RGB 8x8 dot matrix displays that you can use. So quick rundown again. Input stage and gain from the op amp. The resistor divider network breaks down the waveform, goes into your LM3914, which gives us our voltage. Our 555 timer controls our sweep or timing, going into the 7493s are your 1 of 13 counter, which goes into the 4514 drivers, which drives the LEDs. Now, only one LED is on at a time. So, again, I didn't put any type of resistors on the output because you just, only one LED is on at a time. So you really don't, you really don't need it. You can add them if you want, but just from testing it, you would need 32 resistors. So I didn't put them on there. But if you want to adjust the brightness, you would just then you would add resistors, and you could do it that way, but it looks fine the way it is. So let's see what we got. Let's go back over to channel 1, channel 2, channel 1, channel 2. Okay, so I'm gonna do another video. I hope I broke that down and explained it well enough. The schematic's going to be up. I'm going to do another video on all three, where I'm going to go into detail of how, you know, each circuit works for the single channel, the dual channel, and the 3-channel. Parts list, schematic, and I'll even post the PCB layout, which I haven't ordered the boards, but you know, you'll see how it's laid out on the PCB, which is going to be a lot smaller than all this, you know. But this is fun building stuff like this. I had to put it on 2 boards because I didn't have a breadboard big enough. All my circuits, I test them all before I make a final PCB, so this is no different. You gotta build it on here, test it, tweak it, order your board. So go print out the schematic off the website, build this, have fun with it. Like again, with the 550 FAM, if you adjust this capacitor, you can tweak the timing, you know, depending on how your circuit works out. So hope I explained that well enough. Hope you like the circuit. It's a fun project. Go to the website, drop me a comment on this video, print it out. Everything's on the website, everything you need. So have fun, build it, let me know what you think.